Hello everyone. Warm welcome to everyone present here. I'm Akash, and I will be your host today for this GPT webinar. So we're going to be talking about a lot of things related to GPT and how the algorithm works, the overview, the model structure, why we use GPTs instead of transformers for NLP related tasks, etc. So let's get started with what are GPTs exactly. So GPT stands for Generative Pre-trained Transformers, and let's break that into three parts. There's generative, there's pre-trained, and there's a transformer in this. So it is a combination of three things happening. So it is a new class of language models. These models have been recently introduced. I think in 2017, OpenAI released GPT, and the most recent release was GPT-4. So GPT-4 and GPT-3 onwards, they started becoming something called large language models. So the large language models are nothing but a class of models which are capable of generating natural language text, almost indistinguishable from human written text. That means to say that trying to classify something as an AI generated text and and the text a human is given is almost impossible. That is what GPT-4 has practically done. And we will be showing you some results as well. So looking at the timeline, we've started with GPT-1, which the main focus was on unsupervised learning to generate text on various language tasks. So it was trained on a large data set, which I will be talking to you all about. And after GPT-1, there was a slight break, and then OpenAI released GPT-2, which was significantly larger. So it had 1.5 billion parameters, and it started to generate text almost indistinguishable from text written by a human. So this is where researchers used to started getting a sort of panic situation because it is generating such good text that even a human, what a human could do, it was generating that. So it started becoming a concern. Then Google released BERT, which is a supervised language model, which is basically used for fine tuning. So you could use BERT for doing something like sequence classification, sentiment classification, and I will also show you some examples somewhere towards the middle of the webinar where we're doing all such things. And GPT-3 was released after BERT, which has a massive language model with 175 billion parameters. So look at the difference between GPT-2 and GPT-3. It's the difference is insane. But the one thing you have to understand is that all three models have the same structure. It is just a difference in the number of blocks that they have used. So coming back to a slightly more the more described version, a GPT is a 12-layer, 12 attention head decoder. So I will explain to you this with the transformer diagram. So the transformer on the left side is the encoder, and the right side is the decoder. So the encoder is something which is used to convert your text into a sort of masked form, which is what is that is a decoder. The decoder has a masked multi-head layer, but the encoder does something where it would take your text and convert it into a sequence of numbers. We can call them tokens for now, and it performs multi-head attention on it. So attention is nothing but focusing on specific parts of the text. So if you had a three-letter sentence, attention is nothing but trying to figure out the relation between the words in a sentence. So if you had a cat is playing with a ball of yarn, how strongly related is a cat with a ball of yarn? How strongly related is a ball with a cat? So that is what attention is. It is focusing on specific parts of the text. And then we have a normal feed forward network, which will process all the tokens and the attention layer, and it'll feed it to the decoder. So this is how a transformer works. But coming back to GPT, it is only a decoder. So the reason for this choice is because um, it is primarily designed for natural language processing tasks, right? So and the way GPT works that is different from transformers is that it predicts the next word in a sentence by only looking at the previous tokens that were generated. So if you had the main goal of GPT was to do this. Like if you said in Tom and Jerry, Tom is a dash. The goal of GPT was to say Tom is a cat. So if you're going this way, it is a unidirectional model, right? It is only going forwards. Whereas the transformer, the encoder decoder block used to provide multi-directional facilities. So it could go backwards, it could travel backwards through the sentence and predict the future. It would have access to the future words as well. But GPT is not doing that. GPT wants to predict the next token. So that is why it uses only a decoder, because the encoder will also give it will make it bi-directional. But the GPT is a unidirectional model. But there's also something I would like to talk to you all about towards the middle, where GPT, while training, acts like a bidirectional model. So the model architecture is convenient that the first iteration, which was GPT-1, was able to perform question answering. So question answering based on an essay, like you give it an essay and then you ask a question, it was able to give you an answer. And right now, GPTs are being used for semantic segmentation, like brain tumor segmentation, detecting in an X-ray where the brain tumor is, and text extraction, sentiment classification. So I think most of you all must have heard about tweet sentiment classification data sets, right? So GPTs are being used extensively for that. And yeah, so they're just being used in a lot more tasks daily. So coming back to the word split up, they were created to make use of the semi-supervised learning strategy. So semi-supervised learning is a two-step process where it is first trained on a large text corpus, unsupervised learning. So it is trained on an unsupervised data set with no labels as such. So it's just text, like lots of text is just fed into it. Then after that, it is fine-tuned for a specific task, such as question answering or text classification or sequence classification. So this is what it was able to do efficiently and accurately. And compared to an LSTM and a transformer, it also had shown better results compared to both of them. So as I said, semi-supervised learning is the setting where you have a massive size of unlabeled samples and a proportionately small size of labeled samples. So this is your supervised learning set, and this is your unsupervised learning set. So moving on to the transformer. So the transformer is nothing but it is a model which has been developed of late. It is pretty recent, and it is widely used in NLP and NLI tasks, natural language inference. So they were introduced by Google in 2017, and it is composed of an encoder and a decoder, as I mentioned. The encoder takes the sequence and applies a series of self-attention layers, followed by feed-forward. The decoder takes the output of the encoder and generates a sequence of output tokens. So these output tokens are what you see. Like if you see ChatGPT, if you all have ever noticed, it goes one word at a time, right? It goes one word at a time because it is predicting the next word. And it is doing that by this. So the output tokens get mapped back to the word. So it has a knowledge base. In that knowledge base, each token is mapped to a word and each word is mapped to a token. So it is predicting the token, and from the token, it is getting the word out of it. That is how you get your answers from ChatGPT. And the advantage with transformers were that, see, the previous natural language models that were there were RNNs and LSTMs. But RNNs had a vanishing gradient problem. That means that, when you had to ask it something from like the beginning of the like the context, like in an essay, if you had an essay and you said the sky is blue, the sky is gray, and then you suddenly change the color of the sky towards the end and you asked what is the color of the sky, it wouldn't give you the correct answer. So RNNs had a problem there. And LSTMs were then introduced to handle this problem, but LSTMs have a significant problem where they can't handle too much of text. So transformers were introduced to handle a large amount of text. So this is currently the state of the art. So the self-attention mechanism allows the model to capture dependencies between different parts of the input sequence. As I told you, it is used to find some sort of correlation between the words in a sentence, and it focuses on each word specifically. So like if it was, the cat is playing with a ball of yarn, the cat with the ball would have like a relation of 0.8, but the cat with the would have maybe 0.1 and stuff like that. So it is trying to focus on the important parts of the text. And pre-trained is the second part of GPT. It helps with generalization and accuracy. So pre-training is nothing but, I mean, all of you all have used pre-trained models, right? Like such as VGG and stuff like that for transfer learning. But this is different. So it has been pre-trained on a huge data set, unsupervised learning. This is the first part. So the GPT-1 was trained on book corpus dataset. It had nearly 11,038 books and approximately 74 million sentences. So pre-training is the process of training the model on a large amount of unlabeled data, which is just unsupervised data set, to learn some patterns. So what it is doing here is to learn how different words are related to each other. and representation of data, which would be later used to fine tune the model. So it is learning the patterns between text, linear relationships or non-linear relationships, and it is from there whatever it builds on, it'll build on, and then when you fine tune it on a specific task, it will give you answers better. So you don't have to, it won't take time to train again. So the pre-training stage, as I said, allows the model to learn a vast amount of knowledge, which can be fine-tuned for specific tasks. And generative, which is the first part of GPT, is designed to generate new data which resembles the input data. So it is designed to generate text such that the same text should not be repeated again. It does not maintain like a knowledge of what it had generated previously. So if you had asked ChatGPT a question, if you ask ChatGPT the same question maybe 2-3 minutes later, it would probably give you a different answer. Like the code, if you're asking it for a code solution, it might be the same, but if you might have noticed, the description before the code and after the code might have changed. So the generative part of ChatGPT is to generate new data every time. And the generative capabilities are a result of pre-training. As I told you before, it learns a lot of patterns, structure of the natural language. And yeah, so that is generative. Now coming to the algorithm. Before I come to the algorithm, I want to show you guys an example of GPT being used. We'll just show you. So as I spoke to you guys about GPT being used in different cases, so this is one where I have fine-tuned the GPT-2 model to generate a poem defined based on
Can
an
you,
input prompt.
yeah, Akash, can you increase the font quite a bit?
The font, okay. Is this okay?
Yeah, a bit more. Yeah, I think this is good.
Okay. So this is I have three examples. I will show you all one at a time. So this is the one where I have fine-tuned the GPT-2 model released by OpenAI, which is a pretty old model, but I have fine-tuned it because it had only 1.5 billion parameters and it's doable. So I've imported the tokenizer and the head model, which is nothing but it doesn't have anything. It's just empty. It's just the pre-trained model. Then I've imported, okay, so these are just modules I've imported, and I've initialized a tokenizer. So coming back to tokenizers, as I told you, GPT does not have what do you call it, an encoder, right? GPT doesn't have an encoder, but a transformer has an encoder. And the role of the encoder is to convert the text into tokens. But if your GPT model does not have an encoder, how is it getting tokens, right? But that's the role of the tokenizer here. So the tokenizer is an explicit module which will convert your text to tokens specifically for GPT-2, because GPT-2 is trained on a different kind of data set, right? It might not be the same as another model, another kind of, like that's like BERT, for example. The BERT tokenizer has been trained on multiple languages, but GPT-2 has been solely focused on English. So there is a tokenizer specifically for GPT-2, and so I've initialized the model as well, just from the pre-trained model. And now I trained this on a Kaggle dataset actually. So I have already trained it. And this was a poem dataset which had multiple poems, like multiple categories, such as ballads and sonnets and Christian carols. So I just combined all the poems into a text file, just use some helper functions here. And I wrote it. This is the final text file which has all the poems onto it. And I used that as my data set. So I passed it to the tokenizer and I gave a block size of 356. So the block size is nothing but the number of see the sequence length that it can handle. Beyond this, because the GPU can only handle so much. If I give it 512, it means it has to do the same operation 512 times on a single forward pass, which takes too much memory. So this is all just setting up the model, training arguments, giving it a learning rate of around 0.0005, 0.0005, and 10 training epochs, a batch size of 16 and 32. And I started training. So training took quite some time. It had 3,870 steps, and the loss was decreasing, and it reached a stable point beyond which the model just reached end of learning. So, I've trained the model and saved it over here, saved the weights over here, and I'm going to be loading it. So I've used the pipeline model to help me generate text. So I've loaded this from this here. So this contains my weights. I have the weights saved and I'm loading them here, and I'm going to make an inference. So let's say the prompt is a poem which starts with "Love Me Like You Do." So after running it, you get a generated poem, and this is the poem it has generated. So these poems, the data set is different. It's not necessarily like a rhyming sort of a poem, right? It's not a rhyme. This poem data set had stories, etc., as a poem. So this is how GPT-2 works and how it has given you an inference for poem generation. And right, so I will come back to GPT-3 after talking about it. So let's go back to the PowerPoint presentation. Yeah. So let's talk about the algorithm of GPT. So how does GPT really?
So, audience, any questions so far, friends?
Oh yeah, if you have any questions, please feel free to ask.
Akash, Anand this side, and when we do a pre-training, and then when we are taking a corpus, in this case, you have taken a poetry from the Kaggle. What
Correct.
is the minimum size which makes sense so that, like, we were able to make use of our own corpus with the existing pre-trained model? Uh,
Correct.
yeah.
Hmm. So GPT has been found to work with a minimum context size of at least 27. GPT required 27 as the minimum context size. So if you it needed at least 27 words to predict the next word.
Okay. Me, I'm talking about the training corpus. For 27 is an inference you are talking about. I'm
Yeah.
talking about an additional training we have given, right? That
Hmm.
we have taken a pre-trained GPT-2, and then we have given the entire poetry as a further training, right?
Yeah.
That way, what is the
Hmm.
minimum size? For example, I have my organization data, or somebody wanted to do something, and then what would be the size? Maybe in the number of words or the how does that size
The
matter?
context size, right?
Yes.
So the thing is, the GPT model was trained on a book crawler dataset. As I told you all, it had around 72 million sentences. So that was just for pre-training. So GPT-2 built on the same datasets as GPT, but had multiple blocks. So they had multiple decoder blocks. As we had mentioned here, GPT is a 12 layer, 12 attention head transformer decoder, right? So this means it had 12 of these decoders, but GPT-2 had many more. So it was able to give you more parameters. So coming to context size, the GPT-2 context size was nearly at least, I think it was 512, if I'm not wrong, or I think it was either 512 or 1024. I'm not sure, but it was one of these two as a context size for inferencing. But if you wanted to give it a data set, like if you wanted to fine tune it, you would definitely need more than at least 16,000 samples to get a good result.
Okay. Okay.
So
16,000.
does that answer your question, sir?
Yeah, yeah. I was talking about referring the data set only. So it is a
Okay.
16,000 sentences kind of
Yeah.
rows kind of we need to add. Okay,
Yes.
okay, okay. Thank you, Akash.
Also, sound is low, is it?
No,
Not sure.
for me it is okay.
For me also it's okay.
No, it's okay.
Okay. Could you all just try connecting your headphones? I'm not sure why it sounded low.
For me, it's okay. No worries.
Okay. So I will talk about the algorithm of GPT now. So GPT, yeah, so it has 12 decoders on top of each other, as I had mentioned. So this is the first part, the unsupervised pre-training. You have so they're coming to a bit of maths here. So you're trying to do the maximum, you're trying to predict the maximum likelihood estimate or the MLE. So the MLE is nothing but given a few sequence of words, right? Your context size, basically. So as I told in the previous question, like if Tom and Jerry, in Tom and Jerry, Tom is a dash. So if that is the case, the Tom and Jerry, this thing. So if can you see this picture? I think you can see this picture, right? So in the famous cartoon Tom and Jerry, Jerry is the mouse and Tom is a dash. So the context size is 16 because you just count the number of words. You have 1, 2, 3, 4, 5, 6, 7, 8. Commas also included as a character. 9, 10, 11, 12, 13, 14, 15, 16. So you've provided a context size of 16, which is your K. So that is
Akash, font size too small to read.
okay. Okay, this is actually a picture, but
Okay.
I will zoom in this way.
Yeah. Thanks.
Yeah. So I hope you can see this now. So the
Yes.
context size is 16, and we are basically saying that from 1 to 15, we are giving it that much information. and we want to predict the next word, which is 17, like in this case 17. So we want to predict the 17th word. So the answer here would be cat, right? So this is how GPT works. This is how ChatGPT also works. It goes word by word. It does not go like, it does not give you everything at a stretch. So because it doesn't know what actually is there in the future, it is predicting the future. That is how it is different from a transformer. So yeah, so this is your 12 decoders on top of each other. This is the model actually. So so if you see these two parameters, right? So H naught and HL. So H naught is nothing but your the summation of the weights encoding and the position encoding. So your weight encoding is nothing but your token, and the token is applied onto a function. So the converting it to a token is what you're doing with U. So that U is your function, nothing but your tokenizer here. And the position embedding is nothing but where the word is in the sentence. So it is using these two and forming a sort of relation between the words. So it is giving importance to the position of the word and as well as the embedding the tokens, right? So it is trying to perform natural language inference here, because some sentences the wording can be different but the meaning is same. So those kind of cases is where this becomes useful, because it is taking into effect the position of the word in a sentence and the token in the weight matrix. So from there, this is sent to the transformer decoder block, and there are 12 of them stacked on top of each other. These are simple. These just have, as I told you, a self-attention block which focuses on different parts of the sentence individually and tries to build a relation between the different words in the sentence. And it is concatenated with the position embeddings to the former to go to the layer normalization layer. And from there, it goes to a feed-forward layer. And what is going on here is you're trying to find out the non-linear relationships between the words in a sentence. So if you were to say the cat and a mouse, the cat and mouse are both sleeping, the cat is sleeping and the mouse is sleeping could be broken up into two sentences, and you could form a linear relationship saying the cat is sleeping as an action and the mouse is sleeping as an action. But the cat and mouse are not directly related to each other, right? So that is a non-linear relationship. And now decoder blocks are stacked on top of each other. From the final decoder block, you are doing the way GPT works is you're doing unsupervised prediction and supervised prediction at the same time. That is why it becomes a few shot learning model as opposed to having to fine tune it all the time. So that is what it aimed to do. But GPT-1 did not really do this very well, although GPT-2 slightly improved and GPT-3 has very much improved on this task. So the algorithm remains the same for all three variants of GPT. So as I've told you, the procedure is to train on an unlabeled data set such as books and fine-tune it on a labeled data set to evaluate the performance. The weight embedding of the tokens with the position embedding of the words are taken as an input. And this is, okay, so this was your unsupervised pre-training, right? And this is what we have spoken about here. Oh yeah, so after passing it to the transformer block, you get a softmax output from here. After the final layer, normalization layer, there's actually a linear layer over here, which gives you the softmax output. Softmax output could be used in cases of determining the next output, the next word in the sentence. And remember, this is all unsupervised learning still. This is still unsupervised. It's not yet come to fine-tuning. So, right. This is the transformer. This is the GPT algorithm for unsupervised pre-training. Coming to fine-tuning. So fine-tuning is another algorithm on its own. So you're doing, this is simple. You are trying to predict the probability of the next word being something, y, given the set of words 1 to m, where m is again your context size. I mean, how many ever words you've given as an input. So from there, it is trying to predict the maximum probability of y being the output. That is what it's trying to do here. And that is why you have a softmax function on your final decoder of the output from the final decoder block, which is HLM. So HL is each decoder block, and HLM is the final decoder block, and the weight matrix associated with it. So this gives you the loss function, which is summation of log py given x1 to xm. Because py given x1 to xm is just for one sentence in one block. We want it for all the blocks, right, to get the final output. So we sum it over. And now, as I told you, oh yeah, just close the picture. But Yeah. So it is doing unsupervised training and supervised training at the same time. But the loss function is going to be different, right? So that this is one a unique achievement, a novel improvement by GPT, where it does it at the same time. So it is doing your fine tuning and your unsupervised pre-training. It is at least trying to learn the parameters. So it may not give you a very good result, but it is learning. NLI is being done here. So L2 of C is your unsupervised loss function, whereas lambda of L1 of C is your supervised loss function. Why there is lambda is because lambda is nothing but an extra weight added to the loss function, because you are trying to do something supervised, which would require a sort of additional weight associated with it, such as classification or question answering and something specific, right? So that is why lambda is there. And yeah, so this is in basic the algorithm. Supervised fine tuning to obtain the probability to maximize the probability of output class label Y given the sequence X. And this uses the value lambda to weight the loss as the model is doing unsupervised task as well as the supervised task at the same time at every iteration. So does anyone have any questions right now? No? Okay, I shall go on.
See, fundamentally, the algos have been there, right? We have
Hmm?
been seeing these algos, for a long time.
Correct.
But it's
Yes.
just that OpenAI sort of trained it on a very large corpus, right? So,
Correct, sir. So that was there. The brilliance here is not because Google introduced transformers, but OpenAI saw that using an encoder just to. The thing is with an encoder that it will promote bidirectional text like learning, but if you use a decoder, you are doing unidirectional text learning better. So you're focusing on one direction and giving more importance to one direction and trying to improve that one direction learning better, because with multi-direction learning it is getting access to both front and back, but it may not do that well compared to focused one unidirectional model. That is what they have focused on. That is what their entire research paper was on. They were solely focused on trying to predict the next token given a sequence of tokens. So they made smart use of the loss functions and the transformer models to come up with their model of GPT. And of course, the data set was also a very huge data set. So there are also results which show you the comparisons as I showed you here. So as I'll show you here is so RACE is a data set for exams, if I believe. On so you give it a essay, you give the model an essay, and you also give the model a question. So an essay or a paragraph or something, and you ask it a question. These are the performances and the outputs the results that they've got. So the train and the validations outputs. So these are the accuracy and these are the number of layers. So if you had 12 decoder blocks, which is over here, you could get a maximum accuracy of around 85%. And multi-NLI is about it is another model itself. This is another data set. Based on that data set for performing natural language inference with 12 blocks, again they got a good output. So their conclusion was that stacking more blocks does give you a better performance, which was again the sole building block for GPT-3. So this is the performance of a GPT versus an LSTM. Number of updates and this is your task performance out of 100%. So the transformer represented in gray, which is it's just okay, transformer is not shown, but the question answering it is shown here. The LSTM is the dotted lines and the transformer is a solid line. So the LSTM with question answering would achieve a very low score of around 0.02, but the transformer on the contrary could achieve around 0.25. So for every task, it is literally being shown how exponentially better a transformer is compared to an LSTM. So this was one more analysis GPT has made a conclusion for. So yeah, coming to zero-shot learning.
so there is a question
Okay.
chat by Sumit.
Yes.
Check the chat.
Okay. 1 second. Since the accuracy is still increasing for more blocks, are we limited only by compute? Yes, you are actually limited only by compute. That's why GPT-3, the training. So actually what happened in GPT-3, I'll just tell you all the story. So GPT-3, when they trained it, they had trained it using the same GPT-2 architecture, but increased the blocks, right? Which is what they did. But they didn't realize that GPT-2 had been trained using a byte pair encoding. So the byte pair encoding focused specifically on English languages. So GPT-3 suffered from other languages when you're using it for other languages. I'll show you the results as well on that. It's coming up. And the cost for computing training, right? The compute cost is nothing but the training cost. It was very large because they took around 1 month with around 8 GPUs of RTX 3090s or something, and it took a solid month to fully train it. And this was without them knowing the result. Like they never knew what result could have, what kind of results they would get. So they just trained it in 1 month, and it became extremely costly to retrain it again. So yeah, as you said, we are limited only by compute. Yeah. Does anyone have any questions? Okay, I shall go on then. So coming to zero-shot learning. So zero-shot learning is something that OpenAI is targeting towards. That is what they're shifting their focus to, since they have found an algorithm which works from GPT-1. They are just trying to build upon it to create better and better models to perform zero-shot learning. What is zero-shot learning? It is nothing but, so it is a process where you're trying to say that, okay, you're trying to give an input to the model which it has never received. Like it doesn't know what you're giving. It has never seen an output, like a sample output of it. So that is what zero-shot learning is. I will explain in detail a little more. So after you train the network on the massive unlabeled data set of books, unsupervised learning, it was found that the model was performing other tasks such as sentiment analysis, question answering significantly better without fine-tuning. So this leads to a conclusion that GPT model could be a zero-shot learning model with capabilities to perform multiple tasks. But how? How does GPT actually achieve these things, right? So transfer learning, domain adaptation, and contextual understanding are the three main bases for GPT to achieve to achieve zero-shot learning. So transfer learning, as you all know, is nothing but pre-training a model with, basically pre-training a model on a huge data set just for it to understand some sort of pattern. So if you have heard of ResNet and stuff, ResNet and AlexNet, those are also pre-trained models, right? You perform transfer learning on them for your own image classification tasks because they would have learned complex features such as a cat ear and dog ears and stuff like that. Dog ears are droopy and cat ears are always pointed. Stuff like that you would have learned, so you won't have to train it from scratch. So transfer learning in the case of GPTs would be the unsupervised learning part of it. From unsupervised learning, whatever it has learned, you will fine tune. That is the transfer learning part. Domain adaptation is another reason for GPTs to perform zero shot. So there are different domains it is being used in, right? So as I mentioned, there is sentiment analysis, segmentation, question answering, classification. So it is what actually happens in GPT when you say generative pre-trained transformer, you mean to say that the weights are saved, right? You're loading the weights and you're creating a class and you're doing what you want. But the thing with GPT is the weights are changing for each task you do. So if you had a saved state from unsupervised, after whatever weights you get and you load it, let's say you want to do question answering on a specific context, like a specific passage is given to you and you want to do question answering based on that, the domain adaptation comes into play. And what happens is the weights change a little. So you can say that it is again retraining itself in a way, but GPT it is not defined as retraining. So it is still kept it. So they've just left it as pre-trained model that way. But in a way, the weights are changing for every specific task that you do. So for question answering, the weights might be different. For classification, the weights might be different. And contextual understanding is all about, as I told you, providing different kind of context for it. So it can learn better from, the unsupervised data set, given a large context and a large knowledge base. So this is how zero-shot learning is achieved. It should be achieved by GPT, and that's what they're trying to achieve and make a noble achievement in. So now I shall talk about the fine-tuning procedure. Before that, I want to show you all how GPT-3 performs the poem generation. So right now, so Vivek sir has provided me with an API key for GPT-3. I showed you all the output from GPT-2, right? So GPT-3, I am not fine tuning because it is a large language model. I can't possibly fine tune a 175 billion parameter model. And the whole purpose of GPT-3 was to say that language models are few shot learners. That is what the paper is all about. So that means to say, what does that mean? That means to say that without fine tuning it at all, it should give you an answer for whatever you want. That is what a few shot learning is. So it will have some sort of examples and outputs in its knowledge base already for whatever you want. So if I want to generate the same poem with the same prompt, it would give me another poem. So the poems will be different because I specifically fine tune that data set. I mean, on a data set of different kinds of poems, right? So those are like prehistoric poems with stories in them. So this one is more of a fun poem without much
So
literary
you
details.
you fine tune for custom poem, text corpus using GPT-2.
Correct, sir.
If you fine tune GPT-3, which is
Hmm.
API based, is that possible?
Sir, it is not meant to be done. The whole purpose is to not fine tune GPT-3 because it is a few shot learning model. If you fine tune GPT-3, you will be doing what OpenAI did and you would be spending a lot of cost, like a compute cost would be high. And if you fine tune GPT-3, you will be fine tuning it on your data set. Like say you're a company and you have some sort of reports that you want to classify as, some sort of like to HR department, to finance department based on the report. And if you're going to fine tune it, what can happen possibly is that it could also learn something wrong. So it would have already learned and created encodings and embeddings between words, right? But if you fine tune it further, it might learn wrong things. It might
No, but
start
hold on.
mixing
So
up.
I'm sending you a link. Check this link in chat. So they have
Okay.
actually given instruction how to fine tune GPT-3 for
Yeah,
custom
sir. See, the
purpose.
thing is, it is not that you can't do it. You can do it if you want to, for sure.
Hmm.
But I also did consult with somebody in AI who's an industry expert, and I asked him, why don't you fine tune GPT-3, right? Because GPT-2 you're fine tuning, GPT you're fine tuning, transformers you're fine tuning. Why don't you fine tune GPT-3? So obviously the first answer is cost, but then he also told me that whenever you fine tune, it has already learned embeddings between words using the multi attention mask layer. But if you fine tune it, giving it some sort of text and giving it an output, right, it may start learning it wrong. So it may start like whatever we would have learned between the words, the relations, it might start making wrong relations between words. And moreover, if you fine tune it, you'll be able to use it only for that task. You won't.
Actually, yeah. So Akash, let me offer some thoughts here. When I went to that link,
Okay.
see, the word fine tuning, I think it has multiple interpretations here. So when we are fine tuning GPT-3, we are not actually retraining the model.
Yeah,
Okay,
yeah,
what
yeah.
we are doing is actually fine tuning it for custom prompts. So if you
Correct,
actually
correct.
go to that article I have given, they have actually given instructions how to create a custom prompt data set. Okay, so for my prompt, let's say I'm in healthcare space. So for my prompt, what should be the appropriate response? So here
Hmm.
the fine tuning is not on incremental data per se. It is
Okay,
on
okay, yeah,
the
okay.
prompt database.
Oh, so if you have a specific prompt for which you want a specific answer for your own reasons, that
Yes.
is that data set, yeah, that could be done,
It
sir.
is prompt fine tuning, not necessarily model fine tuning the way we understand in traditional machine learning. Okay,
Correct,
so
correct. Yeah,
so,
yeah, that can be
so
done, sir. That
but the
makes sense.
challenge with that is now I have to create a very sophisticated prompt,
Yes,
data set.
yes,
So
sir.
let's say I'm
Yeah,
in healthcare, so I have to have, okay, for this input prompt, answer this input prompt, answer this. So
yeah.
that will need substantial data annotation work for creating prompt. And we have Indrajit and other folks here who work in GPT, so open to ideas here.
Yeah, sir. And also, the same way as you mentioned in healthcare, they're using, as I mentioned, transformers for segmentation and all that. But coming to like for GPT, they tried using GPT for gene sequencing. So genes have a sequence, right? Adenine, thymine, guanine, ATGC. So they use the gene sequence to try and predict a possibility of some sort of cancers in them. But again, it did not. It gave okay results, but relying on such a model for medical purposes is not advised. sir. So that way GPT has to be carefully fine-tuned.
Fine tuning it to that level of sophistication for a mission critical thing like healthcare is
Mhm.
challenging.
Correct.
How many thousands of custom prompts can you design, right? So,
Exactly. Yeah.
understood, yeah.
So yeah, that way, yeah, you can fine tune it if you have specific prompts you want to give. But in certain cases like healthcare, as I mentioned, it you will not be able to give it for all gene sequences.
Akash,
So sorry.
just a, yeah, just a thought. I think on this specific subject, I think what we think is basically you need to kind of differentiate between fine tuning and retraining, right? So
Yeah.
fine, I think what we just discussed is more
Correct.
about
Correct, Vikram.
having specific classification
Correct,
task, for
sir.
example.
Correct.
Sort of say you want to do sentiment analysis where you want to kind of you have a very specific data set where you want to kind of
Hmm.
like John mentioned, it is a kind of an improvement on prompt, right? So how do you do prompt engineering? Sort of maybe you want sophisticated prompts. That's why you go for fine tuning. So there it is not basically retraining. I think retraining has not been offered, on an open mode by.
Yes, sir. Retraining is not the correct word. It is fine tuning. It is extending the knowledge base.
Exactly. But
Yes,
what in
yes, yes.
G4, what they have done is for enterprises, I think they have an option where you can commercially there is a kind of a offering where GPT-4 can be trained on some of your own enterprise data. I think they have done it for Morgan Stanley, if I'm not wrong. So where
Hmm.
the GPT-4 is kind of custom trained on Morgan Stanley's data, where it is being used by their financial advisors. So there is a kind of retraining play which is coming up more as a commercial offering. But I think for the open one, so far it has been only fine tuning where you can kind of specifically fine tune and get your task done through the particular mode.
Yes, sir. Yes, sir. So so that is exactly correct. That is true. Fine tuning is all about extending the knowledge base, not about retraining it specifically only on your knowledge base. That is not what fine tuning is. It is just extending your knowledge base to support the additional prompts that you give to it. So that is all about fine tuning. And
I think Vikram is saying in GPT-4 they have offered
hmm,
enterprise grade incremental machine learning. So OpenAI will do it for you. If you are
yeah,
Morgan
okay.
Stanley or Stripe, in fact, couple of these companies are early users of GPT-4, and where OpenAI has done the custom model training for these companies.
For the
That
companies,
will
got
be
it. Okay.
enterprise level engagement with OpenAI, not for us or developer base.
Okay. Hmm.
Because
So
it will need internet scale cloud training, which none of
So,
the other companies or us developers would have anyways.
yeah, so
Hmm.
So I have one question here, Vivek and Akash here.
Yeah.
Yeah.
So when you say that, see, when they are AI are giving APIs, right, for the
Yeah.
GPT, right? So what is the purpose of that, right? Is you are saying it's already zero shot learning, right? And I have a lot of my enterprise data, right? So what should we do? Should I retrain it, or basically generally, or I have to fine tune it? So I'm just a little bit confused. So what is the use of the APIs? How do I have to leverage my own data, which is there in an enterprises?
Sir, so the API, the whole thing about an API is it's called an application programming interface.
Yeah, I
So
understand that.
you are
Yeah.
given a key, which means that so that key is nothing but an access to you using the GPT model. So
Yes.
as I showed you in the poem, this one,
Yeah. Yeah.
there's a key here, and I have just selected an engine, and because I have a key in an OpenAI account, I'm allowed to use the one GPT-3 engine of theirs.
Yeah.
And that is, I am just using the existing GPT-3 model, which was just trained on the unsupervised data set. I have not done any fine tuning here.
Okay.
For your case, since you have a specific data set of, like as Vivek sir mentioned, of prompts, for example. So if
Mm-hmm.
you have a sort of data set of such a format as sir has mentioned in chat, so an input and an output. So if you had a prompt, like some sort of prompt and the actual expected output, then you could use this data set to add it to the knowledge base of GPT-3. So what I mean by knowledge base is the fine-tuned
So basically, this should
parameters.
be in this format of JSON object, like something whatever you have shown here.
Something like JSON, or there's also a pandas
Mhm.
format, right? Pandas CSV format.
So I cannot fine tune with any data like which is in any format. It has to be in this format. Then only I can fine tune it.
So some formats are accepted by GPT. So there is PyArrow, there is Pandas, and there is also another sort of class called from Pipeline. So
Mhm.
text data set. So using text data set, you can build your own data set. It's called a series dictionary object. So
Okay.
these kind of data sets are accepted by GPT-3 and by GPT on the whole. So it
Are
you
there
will
any tools? Are there any tools? So if
There
I have a
is something called LangChain also. Akash or Nishant or Indrajit, are you familiar with LangChain?
somewhat
I think
familiar with
Nishant is here.
LangChain.
Nishant, you were mentioning LangChain before.
I think Indrajit is on mute.
Vivek, I tried LangChain. For example, when we take any huge transcript, it does the semantic search of that
Okay.
entire text. How
Okay.
does that it searches? That is, we need to check detail. But LangChain gives you a very meaningful semantic search instead of a normal search in a very cost-effective way. Otherwise, earlier when we used to do talk about Elasticsearch and other searches, now when we have huge corpus with the LangChain model built in, I'm able to do more meaningful searches from my corpus.
Mm-hmm.
Okay.
I just tried one YouTube and then downloaded the entire script of transcript of 15 minutes, and then I asked questions, contextual question: who is the speaker, what he's talking about, and then what is the details of this content. It beautifully gives an answers.
Yes, sir. So I think LangChain is built on the question answering models available. So they have built onto the question answering model available on Hugging Face. So actually, I do have this question answering case over here as well. So this is one pre-trained model from question answering which is there on Hugging Face.
Mm-hmm.
And I think LangChain must have either used a combination of the models together, like reinforcement, I mean, not reinforcement, ensemble learning, and created a huge model which will do question answering for you again unsupervised way or by giving it a context.
Yeah.
Okay.
Okay. So, Akash, one more query. Like, if
Yes.
I have docs, like PDF docs or Word
Hmm.
docs, wherein I have some enterprise data,
Okay.
let's assume that I want to look at health and safety data. Now, I want to train it on health and safety, and then I ask it a question on health and safety, and it is able to give me a response back.
Okay.
It may not be previously trained on health and safety, and for me that health and safety information may be available in some PDF docs or Word docs or maybe in CSV.
Okay.
So how do we do that part?
So what you are looking at is again fine tuning. It is not about retraining. It is specifically trying to target based on your in specific prompts and inputs, right? So if you had like and GPT, by the way, works with PDFs, text documents, and other formats. You just have to load it in different ways. There are different loaders for each format. And by loading it, like say you have a Google, like a Word document with the prompt and the expected output, one below each other. So the thing is called a delimiter. So you have to give it a uniform delimiter, like a CSV has a comma, JSON has a comma, and if you're using a Word document, you could provide a line break or some sort of unique character. Because if you provide a full stop as a delimiter, it might think it's part of the same sentence. So it will work with documents and PDFs, but you just have to provide appropriate delimiters, and you will be fine tuning it, not retraining it.
Agree. Is there um, any information available or somewhere that how do I go ahead and fine tune it?
Yes, sir.
How do
You
you
can.
upload the documents or so that the model gets trained on this data?
So you can check out the OpenAI docs as well. They have a very good implementation, as Vivek sir also mentioned. Sent a link on fine tuning GPT. So this documentation has the general for instructions for fine tuning GPT, but GPT-3 specifically. But if you wanted to look at loading on the different Word documents or different PDFs, you could just ask ChatGPT again. So yeah, there are definitely quite a few guides available for loading them. I've seen them personally because I also asked the same question to GPT a few days ago, and it did give me an output.
Excellent. Thank you. And similarly, like we can do it through voice also. I thought in GPT-4 voice was also supported. That
Sir, voice
once
was
I
also.
have trained it, fine-tuned it on a specific data set,
Mhm.
then I like ask it in voice and get a response back in voice.
So voice is still in development. If I'm not wrong, they haven't released vision as well yet, but they have got results from vision, like by giving a picture as an input. But voice is still in its development stage, although they are trying to release that quickly.
Okay. And one more thing, like typically when I look at conversational AI, there
Yes.
is a closed format of question and answer or some kind of
Mhm.
checklist. Now, if there are few things wherein I want the OpenAI to respond, and then there are few things which I want to have it as part of my workflow, wherein I know what is the response and the next question that I should be asking the user. Because not every time I want the like there are few responses which I as a user know or as an enterprise know,
Mhm.
and there are few things for it for which I want the chat GPT to answer. So how could I have a customized workflow wherein I can initiate OpenAI for some things, basically chat GPT for some things, and for some things I know the answer and I should be able to put those details. Because typically lot of use cases are going to be conversational AI use cases that would
Okay.
come in as far as the user.
So if I understand your question correctly, you're saying some questions answers you will know properly, and you want to use that in response for next questions, right? In some cases.
Yes.
So that way, what you could do is, since GPT has the memory capability, so it does remember at least up to like I'm not sure the exact number of words, but it can remember up to quite a few characters. I don't know if you have tried this, but if you put a line of like some amount of code onto
Mm.
ChatGPT and just press enter, it'll just give you a description of the code. But then like 2 3 times later, if you say and if you do something else, and then like after like the third time you call again, you ask a question on the first code that you asked, it'll still give you the answer. So that way, if you want some answers to be GPT and some answers to be yours, what you could do is like if the person asks the question, you could give the answer simultaneously as the output, expected output. And if GPT's answer does not seem to match what you want, you could eliminate it always and just pass it to GPT's knowledge base. So you could do that.
Yeah, yeah. To add to
Okay.
Akash updates, and Nirav, actually, what you are asking is it's an industry problem, right? So we
Yes.
have some answers to the customers. We cannot just a fluke. We cannot tell, even however accurate it is. GPT is. We need to take it from our enterprise knowledge base, and we need to give them accurate answer about what is our policy pertaining to that customer, right?
Exactly.
Yeah. So we need to mix a world of how I can make use of a GPT and then how I can make use of my internal knowledge base. That has been traditionally done. Maybe what I'm also interested to see that, but the rough idea would be like, we, our main, the power, how we need to use it, like how I am understanding my customer queries. In a conversational AI, it can be in a voice or it can be, yeah, conversation again, obviously it's in a voice, or even if it is in a chatbot,
Mm.
we need to try to understand the customer queries. So we need to try to understand the intents and all. How
Exactly, sir.
within a
Exactly.
few keywords, how I am able to understand saying that no, okay, the customer is trying to ask about this question. Then I will have a list of stuff in my backend saying that no, I related to this particular case with the number of 100, 101, like that. I will keep connecting with my backend and then we'll give it. Currently, how I can give a open output what the GPT is given directly to the customer is, I don't think like we can give that in enterprise settings. But what we can use GPT is to better understanding the customer queries and map it with my knowledge base.
Yes, sir. Yes. As sir, also what you had mentioned, right, about the person learning better than, I mean, understanding from a few words what the customer wants. So that
Correct.
is exactly natural language inference, which is something GPT struggles with actually. It is
Oh.
not able to. So GPT, I have also added this in my slides. I will show you all. But since we're here talking about already, I'll just mention it. NLI is something GPT is still struggling. Even GPT-4 is still not perfect, which is why you can't replace jobs yet with GPT, because it can't build perfect correlations with words as a human can. It can't do that yet. So people saying jobs will be removed because of GPT is, it's not going to happen, because you as a if you are a, like a marketing strategy person, if you're trying to understand your client, you wouldn't want to rely on something like ChatGPT, because it may not understand your client with whatever like perfectly as you might understand him better. So natural
Correct.
language inference is something that they're still building on, and it is not yet perfect. So
Currently, we might use a very simple like TF-IDF, and then from there understanding the question similarity, and then map with my knowledge base. But in this area, how I can bring in GPT's power is yet to explore, Nirav. I think we can discuss. Which industry you belongs to?
Yeah, I am into conversational AI
Okay,
chatbot.
cool then.
Yeah,
We'll
yeah.
discuss.
Because I believe that is where means the maximum usage is. But as of today, when I look, I I find difficulty that if if ChatGPT is going to understand the context of the query which a customer has put in, and I like today I would have I would be doing that analysis, and
True.
I come up with a response based on the analysis that I have done.
We need to manually make the
Now,
prompts. Yeah,
yeah, then we are saying that both the chat GPT also has to come with its own analysis. I have to come with my own analysis. And then there has to be a third thing which was going to say which is better of the two, and continue to train. And then finally, at some stage, we are in a position wherein we say, okay, these responses come from chat GPT, and these are the ones that can come from internal. But yes, I am looking at a way wherein if chat gpt is the one that is going to, how I can fine tune it so that it understands what needs to be responded back to a customer, because otherwise acceptance in enterprise setting is very very
yes.
difficult.
Even you, let us say that no, we have a kind of an assuming a simple kind of an Excel where it says that no, I have an embeddings, and then final, if this is the intent, I am mapping it with my 1,000 answers. So even that is been taken care by GPT. Instead of doing a manual mapping, if GPT is able to understand saying that no, without explicitly programming as like anything, if it is able to understand from our only our knowledge base, that would be a beautiful, like completely make use of a GPT's power in our corpus. That is the, I think, expected, and very very helpful in industry segments.
Yes,
yes,
and
sir.
that is what my first query was. If it can be fine tuned for, suppose, just as an example, health and safety standards are there. I want to fine tune it only on health and safety, so that as a customer, then when I ask any question on health and safety, it gives me response only from the data with which it has been fine tuned with,
True.
not with anything else that it has learned.
Yeah. We need the power of knowledge, understanding, language understanding, and response quick with the minimum set of inputs.
But today, see, if I have to look, today it has all the information based on all the learning it has done with all the docs, all the code which is there in GitHub.
True.
All that has been already done. So my feeling is that internally the engine is strong enough to, like, if I give it any knowledge base, to create those corresponding embeddings internally and provide me responses. The only thing is the expect, wherein I train it with a limited data based on all the corpus that I have internally, and it should just provide me response from that. If that can be done, I would be happy enough.
Same here, Nero.
Yeah. But
So
what
we
I
have to master this prompt prompt engineering for custom.
Vivek.
So Vivek, what I feel is there should be a tool which will kind of create you give it in text any format, right? It should generate your prompt engineering.
Actually, there are models we have seen now where they are helping you with creating this prompt mapping.
That is what I'm asking. That's what I'm asking.
Yeah.
So there are meta models which are helping us, but yes, they are still new area. But we have seen some references where they say, okay, I'll help you design prompts, basically. Because the new thing in programming word is English is the most glamorous programming language now. So it is all about how you frame the prompts in your custom prompt mapping. And then you can fine tune GPT to make it very strict as to, okay, please, as per my prompt only, don't give me all your worldly knowledge. So I think you can control those factors in the fine tuning.
So when you say prompt engineering, just trying to understand. So it's basically a kind of a question and answer, right? Name value pair.
Yes. So you see the example in the chat.
Right.
So.
But Vivek, it would have been little more. The objective should be little more, because when I try to do that, I will be exhausted with the kind of question and answer. Instead, that intelligence should be there from a PDFs, multiple different documents. I just give that, open up the folder, like let us say one S3, and then it has to intelligently learn from that how GPT has been trained. I don't know how. Anyway,
No, sir,
we are
it
talking
is.
about that.
Yeah, as I mentioned, it is possible to load such documents for fine-tuning purposes. It is possible.
Correct.
It accepts. It is. It is not that it is trained. It's not that it's trained only on the text, right? It has been trained on books. It has been trained on scanned copies.
Yeah, that's what my
It
question
has been trained on Excel sheets, on web links. It has been trained on YouTube links. It has been trained on so many things, right? So there are multiple formats it has been trained on. So I think any sort of textual data, you will have to ideally convert to a universal sort of data set. So what GPT has done is they have their own sort of format, and other format you can use is Hugging Face's format called a series dictionary. So both of these data set objects are available, and you will have to ideally convert whatever PDF, Word, all that. You can load everything, but all of that together should, as a one data set, should be a series dictionary. That's it.
So, Kamalesh, I just want to understand. You said you have used that Kaggle data set, right, to fine tune this.
Correct.
Can you show me the format of that?
Oh, that was just simple text files. I actually don't have the link right now.
Okay.
But it was just
It does not. It is not in a prompt format, right? I'm just trying to understand.
No. It is unsupervised. It is just unlabeled, just text of poems.
So like if I have let's say that for a law someone wants to do this content, right? Your GPT-3, whatever it is there. So I can take a lot of content in the basically in the contracts or a law books, whatever is there, right? And I can can I fine tune with that?
Yeah, sir. So you could do that to do some sort of contradictory statement detection. Like suppose in the contract you have mentioned some amount, and later again you mentioned some different amount towards the end, then it will detect an anomaly like that. People are doing that, sir. So actually, there is a research project in my college itself which has done this. So they have done this exact same thing to do contradictory word sentence detection and warnings, basically. So any sort of, like, if you just feed in a textbook, right, or like a research article before publishing, it could detect any anomalies between sentences.
So basically here there is no prompt format that is you are giving, right? That's
No.
But Suresh, that is for the GPT-2. How we need to do it in a GPT-3 still unknown. That's what Akash also said.
GPT-2, right?
Yeah.
Sorry.
Yeah. GPT, even if you take our external content, how does it matters? That is still unknown. They are not given also, I think, or we don't know. But GPT-2, we were able to give a quick, simple CSV, which can be an entire Shakespeare songs or whatever it is like that. And then it is able to generate.
Yeah. So Anand, then if that is the case, right, for my proprietary data, I can use GPT-2, right? So what is the value add with GPT-3? I'll get it. I'm just trying to kind of.
Yes. I think even I'm also in the same status, Suresh. I feel like, when GPT is giving the option to us, let us use GPT-2. And then once GPT-3 is becoming more clear, and then we should adapt to GPT-3.
So the thing is, actually, GPT
to fine tune the models. So in the Hugging Face, we have the access to a GPT-2, and with the help of that, we could easily
Correct.
fine tune.
That's what I've also shown as an example
Yeah,
in
yeah,
the code.
you
So,
should.
sir, the thing with what you said about GPT-3 being unknown, it's not unknown. The thing
Mm,
is, it is also unsupervised. It is also unsupervised only. So, if you wanted to, I could do the same poem thing with
mm,
GPT-3. But
mm,
the value add is that GPT-3 has multiple decoder blocks. So,
mm,
GPT-2 has a fewer number of decoder blocks compared to GPT-3. So, it
mm.
has 1.5 billion parameters. So,
Okay.
but GPT-3 has so many blocks that it is able to build more relations between the words, better NLI, and you will get better contextual understanding of your answers. That is why you would go for GPT-3.
No, but see, as long as I have my proprietary data in for some particular domain, right? I
Yeah,
think, see, I don't want to unnecessarily create a relationship. Let's take an example. Let's say a screw or a bolt, right?
yeah,
The way you take it in an electronic industry may be different, in a mechanical industry may be different,
correct.
right? So when I try to fine tune with my electronic industry, and I'm more worried, I'm not worried about other contexts of that screw or bolt. I'm more worried in my electronic industry.
Oh, that
So
is GPT-2 will be enough, sir. Yeah,
exactly, that is what I'm trying to say.
correct, correct. That way, if you were, suppose you were an on-site like engineer and you said in one case it is used in the mechanical, in one case it is used
Mm.
in the electrical,
Yeah,
then
yeah,
GPT-3 will be better.
yeah. So basically, I think what I'm trying to say is that, especially, let's say for a domain, particular domain, right?
Correct.
See, it's like a human. You give him more information, is really confused. With
Mm-hmm.
GPT, see, if I have to develop an application to a particular industry, right?
Yes.
So a particular word has a different meaning in that context in that particular industry. In that
Mhm.
way, I feel, again, I may be wrong. The GPT-2 might be more than sufficient for me. With GPT-3, I'm rather confusing the by giving unnecessary information, rather unnecessary context.
No, sir. Actually, I'll tell you why it's wrong. Because if you use GPT-2, as I
Mm.
said, it has the natural language inference. Because you said you are trying to build, like, you're giving it specific sort of inputs, right? So
Yeah,
if
yeah.
you're giving it a specific sort of input, it has to first understand what is going on in the input. Let's
Yes.
take fake news detection, for example. If you
Mhm.
were to put a data set of fake news, real news, and then the category fake, real,
Mm.
zero or one,
Mhm.
if you put this into a like a transformer and then you give it an out, like you ask it to predict, there are
Mm.
very high chances that it will start overfitting because it does not do NLI properly. So
Okay.
better, more the NLI, more the better chances of you getting a contextual output that matches what you want. So if you were to do something where there's no natural language inference, like in this news detection, ideally what should be happening is it should be like you should have a web crawler which goes through all the important news websites,
Mhm. Mhm.
gets the news from there and the title as well, and then do some sort of sequence classification. But if you just give it one paragraph and say
Yeah.
fake or real, it won't understand.
No, I see a point, but again, yeah.
So
Yeah,
that
again, but
way, very specific use cases will require the different model as well.
got it. Got it.
No, in coming days, I think we will have one group presenting GPT-2 and GPT-3, Vivek. Like, we will see which one is better and more
Yeah,
customizable.
Anand, the problem is these OpenAI and Google and Facebook are launching models like every day nowadays.
Yeah, yeah.
So,
But
I mean,
but
this
they
is
are not
today's
revealing the
technology.
information. They're
No, no, see,
launching it every day.
See,
Just
see,
releasing
whatever
it.
launching
we
is
are
one point,
discussing
right?
is
See,
as of today.
launching.
Tomorrow, things will change. Okay, every day.
No,
Next month, we will be in a different position, our understandings and then our ideas, everything.
Yeah, the
So,
way it's going next month, we'll be on Mars. Okay.
no. See, Anand and Vivek, what I'm trying to say is that, see, there can be multiple models that may be coming up, and see, with GPT-3 to GPT-4, you have more data doing all this stuff and more decoders using it. My only point, what I'm trying to say is that, see, I am a startup. Let's say I'm into healthcare, right? So I'm more worried about my prompt engineering from a healthcare perspective, right? So if I take GPT-2 itself with whatever intelligence it has made, correlations between different words, and now I fine tune with my healthcare domain content, right? That is more than sufficient for me, right? I'm just trying to, let's say you
Correct, correct, sir. Yeah.
let GPT-5 come, GPT-10 come. I'm least bothered, okay? This chuma, every day you are getting some other content. It is trying to build relationship. I'm not worried about those relationships. I am more worried about my domain, particular specific words and context of that word. In that way, As long as GPT or GPT-3 gives me a handle to kind of fine tune with my,
Mm-hmm.
I feel that is more. See,
Yeah,
you
it would also reduce your computational cost as well
exactly,
if you use
exactly, right.
GPT-2.
That's what companies want also, right?
I
Yeah.
mean, that's
No,
why
but
people
Surya,
like us,
when
communities like
yes,
us are trying to bridge the gap from algos to reality, right?
Huh, huh, huh.
So we are trying to work with multiple. We have clients in US. We are already getting requests for the llama thing and the alpaca thing. Alpaca was launched like 2 days back. It's a
Yeah,
wrapper around llama of Facebook. But yes, so people like us are the ones, or all of us here have to really bridge the gap from
exactly.
these breakthrough algos coming every day and to actual business reality. So
but
Yeah,
at the same time, we need to remember one thing. I don't know. There is another direction to it. It's like OpenAI, while putting all the efforts and then releasing it, how far they will allow us to customize and take things in our control instead of relying on them. That's also a
Mm.
question because then otherwise the business model and the what is the
yeah, yeah.
earning potential for them. If they give everything, okay, this is the power I'm giving to you. You do whatever it is. Instead of that, they might keep something in their hand so that like we go
exactly.
back to them
Yeah,
every time. And
and
API access charges and everything,
Yeah.
level of customization and the cost increases.
But
Might be that will be their
you
strategy.
never know the model size that you're using with the API key, right? Like it might be any random model. It might be
True.
2 billion parameter. It might be 20 billion parameter. It might be even be a 1.5 billion parameter.
so that's what I'm saying. No, see, why are you worried about 1 billion or 20 billion or 30 billion, right? As long
Mhm.
as my million of data of my domain, it is solving the
Yeah.
problem.
Yeah,
I'm
yeah,
good.
yeah.
But
Correct.
if it's related to your domain and it does not need to, so why do we need to retrain ones? So
Agreed.
you
Agreed.
use your own model rather
Yeah.
See,
than
the thing
fine
Some
with
tune.
some
Yeah, let's try
information, right?
to, yeah,
So what?
folks, let's try to move ahead with this webinar, but great discussion. But we have to try to wind
Vivek, one silly question. Sorry, let me ask you.
up.
I could not control myself. See, basically, this fine tuning and all. So we used to have a transfer learning concept, right? Before.
yeah.
So
Yeah.
is this transfer learning and fine tuning is kind of related?
No, here the words, the interpretation has changed, right? Here, fine tuning means that prompt engineering, and transfer learning is what Morgan Stanley and Stripe are already doing directly as an enterprise clients of OpenAI. So we can't really incremental ML or transfer learning we can't do because we don't have access to the GPT-3 code base and the large language, and we don't have that compute power either. So we can only, do transfer learning on GPT-2. That we can do, but with GPT-3, we can only do prompt engineering based fine tuning. That's about it.
So I can also tell that in a slightly different way.
Hmm.
If you see this, I have shown you. I have loaded the LM head model. So the head model means it contains very few layers, right?
Okay.
So that does not mean I'm doing transfer learning on the entire model that is there. I am
Okay.
using the first few layers itself because
Uh,
I can't like on my GPU or on the in general like you get like a 16 GB GPU, right? So on
mhm.
that 16 GB, 32 GB GPU, only the first few layers can be handled because as I told you, OpenAI use like around 8 to 10 or 32 GPUs if I'm not wrong. They use
Okay.
so many GPUs to fully train with all the layers stacked on top of each other.
Okay.
So we're using the head model. It is sort of transfer learning, but it is not actually transfer learning. The difference has changed now for NLP.
Okay. Yeah, I'm
Okay,
not. Yeah, a little bit confused, but yes, let me do some
it
reading.
is something like transfer learning. You can say that.
Okay. 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 Yeah, sorry,
So
correct. I should not stop you.
No,
Yeah.
no, no, fantastic inputs. Certainly very fascinating discussion. But yes,
Yeah.
this discussion will go on, pretty much every day now. Tomorrow there'll be a new model in town. So we'll keep discussing through these sessions. Yes.
No, no. Yeah, my whole confusion was this transfer learning, fine tuning, and retraining, right?
Fair question. We are all learning on the fly because these algos are coming to us every day now.
Yeah. Okay. Yeah, sorry, go ahead.
yeah. Okay, so coming to fine-tuning GPT for different tasks. So this is a diagram I've taken from the research paper itself, and this is as I showed you earlier the model, right? The decoder model with the text and position embedding vectors. So if you're doing something that is classification, sentiment classification, or classifying sentences as correct grammar or not correct grammar, so start is like it is nothing but like a flowchart. So you start your task, you provide the text, whatever text you want, and you extract it. By extracting it, you are converting it to, you're tokenizing it in the case of GPT. So you're sending the tokenized text on the position embedding matrix to the transformer. Then the transformer here is nothing but GPT, which is nothing but these 12 decoder blocks. Then you're sending it out to a linear layer. And the linear layer is this final output here, which is not shown, but there is a linear layer here, which will give you the softmax output. And that will go to your text prediction and your classifier layer. So this is your classification purpose, which comes here. Supervised learning. These are all supervised learning tasks. So entailment is all about, as I told you, detecting a contradiction in like two statements. So this is one premise and your hypothesis. So if you say like a premise such as like a dog is lying on the floor, and then the hypothesis is that the dog is, what do you say? The dog is running. So it will say that they are contradictory statements. So the same way, there's a delimiter here. Like as I told you, delimiter could be a line break or like a dollar sign or some sort of unique character, and just to indicate that these are two different sentences. So from the transformer, you get a linear layer again, and the similarity to detect how similar two sentences are. No, sorry. So if you give it two sentences and you give it in different orders, will you get the same output? Because will the order of your sentences in a paragraph, for example, affect your output? Is what they're checking here. And multiple choice. And if you notice here that in these cases, the
Kamalesh, in the first one, and the similarity, you mean to say that the order of sentence also means it takes the context to say that they are similar? Or
Yes, sir. The context itself is becoming different, right? The context will be for the first case, the first sentence, then the second sentence. Then the second case, the context will be the second sentence and then the first sentence. So both of them are passed to different transformer layers and they're concatenated to one linear layer, which will give you an output of a softmax saying that is it really similar or is it dissimilar?
Interesting. Do you have any example?
Okay, similarity I don't have actually because I thought I would only do three.
No,
But
that's
on the research paper, there is a very good example they have shown.
I'll go through that.
And coming to multiple choice, so this is like multiple choice questions, like given a knowledge base, like a context. So the same context is given for each answer. So like let's say you're given like a question, like a paragraph, and you've asked it a question, and and you've given four options as the answer. So each option, along with the context, is tokenized and separated. The context is separated from the option, and each of them is sent to a transformer, the GPT model, and then the linear layers are obtained, and you get the probability of which one is being the correct answer here. Is it option 1, option 2, option 3, or n? So that's what this bar graph determines. Which one is the most probable answer?
So probably there is a softmax layer there.
Yes,
which
sir.
is
Yes.
doing the max.
Because we are doing supervised, right? In the end, so of outside, the final activation from the linear layer is going to be a softmax.
Sure. So in general, compared to like here also it is transformer. Sorry, maybe I joined a little late.
Okay.
But what is the critical difference when it comes to a transformer and GPT?
Okay, so I will go back. Okay, can you just remember this diagram? So this diagram
Yes.
has 12 such blocks, right? So
Yes.
these blocks are one of the blocks of a transformer. So this is a transformer actually. So what GPT has is it has this. It has this block. This is a block.
Just a decoder, no encoder.
Yeah, no encoder. It is just a decoder. And as you can see, after the linear layer, there's a softmax, which gives you output probabilities. So these are a stack of 12 decoders, and they do not have the encoder layer. So the job of the encoder in a transformer is to tokenize your text. And that is what is happening in the positional encoding. So the positional encoding is nothing but the WP matrix, the vector, and WE is your tokenized function on the inputs. So that is what you get, and that is what is passed to the multi-head attention block of the decoder. But what is happening here is because in transformers, it provided the option of bidirectional word predictions. So it used to have the context before and after the current word. But in GPT, the goal is to predict the next word in a sentence. So if you were, I gave an example of, I don't know.
No, it is called auto regressive decoder. So it trains on itself. It doesn't need encoder. So
Correct.
it trains on itself by masking the words or because it knows the Y level, which is the next word or the masked word.
Did you see the slide, sir? Did you see this?
Yes, yes, I think I was here
So this
Yeah.
is
when you
called,
were taking it.
self-supervised learning,
Correct.
technically.
So what we're doing here is we're trying to maximize the likelihood of an output given the context size. So here we're trying to predict the next word, and we're trying to maximize our prediction for the next word, and that is nothing but UI here, which is the current word you're trying to predict, and UI minus k till UI minus 1 is your context, which is from the beginning of the word to where you are. That till there is your context. So the way the transformer works is you get the entire context and you try and do some sort of prediction. But with GPT, you're giving it the context limited time, like only up till where you are. So based on the previous context, you're trying to predict the next word one at a time. And theta here is your model parameters. This theta. This is this is your model parameters. And now the as I told you all, the weight embedding matrix is tokenized with the U, and WP is your positional embedding matrix. This goes to 12 transformer blocks, and the output is a softmax from the final transformer block. Is that does that make it clear, sir? Why
Yes, yes,
GPT
yes,
is
I got
different?
it. Got it. Got it. Thank you.
So yeah, so as I told you all, why GPT over a regular transformer? So the original transformer is designed for bidirectional language modeling. So the model is trained to predict the next word based on both the preceding and the following word. So the entire context is given to it. But in contrast, GPT is a unidirectional language model. The model is only trained to predict the next word based on the preceding words till that word. So it allows GPT to generate more coherent and natural language text because it can build better sort of non-linear relationships between the words until the current word. So the two-way decoder method used in GPT involves training two separate decoders for the forward and backward directions. So as I told you all, you are trying to predict the next word, right? But the actual way, like the way in practicality, it is not possible with just one direction. So so how it works is every decoder, right? In the decoder block, the second masked multi-attention layer will go backwards. So that will, it'll go forward, sorry. So it will have the positional embedding from both the forward direction and the backward direction up to your context, whatever length. And it tries and maps each of them to a sort of, what do you call that? The attention
Attention.
score.
Yeah.
Attention score. So it gives you the attention scores based on the forward and backward. Because one more thing GPT does is some, like, let's say, let me just show you on a whiteboard. It'll just make it easier. So if you had like a word, right? So you said the something, and you don't. So what it does is like you give it a sentence, and then it does something. The bird is like this is the word. The word this word is bird. But what GPT does is it masks this. Okay, so it masks it, and so the model is ultimately trying to predict this. So to predict this, we need to have previous and forward, right? Like I won't know what this is just by having the. So that's why while training it becomes a bidirectional model. But that's only the but in architecture wise, it is still a unidirectional model. I hope you understand what I'm saying.
Yeah. So basically, while training, it is using both forward and backward.
Yeah, that's
It's a
that's the way
transformer
it
kind
works.
of.
It will go forward. It is not using a transformer way. It is just that the way it is training appears to be bidirectional, but
Yeah.
it is with a unidirectional context.
Got it. Got it.
So that is what GPT does. And one more thing about GPT is it focuses specifically on, like you as we said, it's a unidirectional model, right? So it focuses on generating better text on one direction rather than focusing on two directions like a transformer, and maybe not building strong relationships between your words in the context. So you get better natural language text. So let's come to GPT-3. So this was, as I told you all, I mean, I've told you all many times, it is been trained. The goal of GPT-3 was to perform zero-shot learning, but it was not able to achieve this goal. So it has been called a few-shot learning model. So there is no change in the model architecture. It is the same decoder blocks layered on top of each other. The tokens can look at themselves and the previously arrived tokens. So the data set used was a different data set. I told you all that for GPT-1, it was a books corpus data set, right? So here we have used the Common Crawl. So Common Crawl was a web crawler which crawled through Reddit links a lot of browser histories, and it was actually a privacy obtrusion tool, but it gathered a lot of data from the web, like Wikipedia articles, news articles, journals, and everything basically, and Reddit links, whichever. Like suppose for code, right? So how it worked for code, generating code was it looked at all Reddit links, GitHub repositories which were ranked high. Like for a specific task, whichever was the top three ranked links, it used to crawl through them and get the code from there. So that is what the dataset was for GPT-3 plus web text. Web text is is your links to websites, YouTube videos, etc. So if you were to say, I want to use not a YouTube video, but I want a tutorial for making some sort of thing, it would go to one YouTube video and look at the transcript and try and give the same thing to you. Again, generatively, so it might be different. The actual transcript and what it generates will be different. So that is one small description about GPT-3. So GPT-3 has one shot, few shot, and zero shot capabilities. One shot represents most accurately the way humans work, so it makes a prediction with just one sample provided to the model. So in detail, it is explained over here. Let's start with one-shot learning. So in addition to the task description that you want, right? So this is your task description. You want to translate a sentence from English to French. So in addition to this, the model will see a single example. So you give it an example saying that sea otter is l'autre de mer. So you give it an example of how it should work, and then you give it a prompt. So that is what one-shot learning is. So you give it one example and it will see how it's supposed to work, and then you give it your input. That is one-shot learning. Few-shot learning is an extension of one-shot learning where you give it more examples, a few more examples, and then you give your prompt. And zero-shot learning is what it is trying to achieve, where you give it the sentence directly without giving it an example. And one thing to note is that there are no gradient updates performed. That the weights are not changing. There is no forward prop that is happening here. It is just an inference. And so this is what a transformer would do. It would perform gradient updates. So every time you performed an inference, it would keep updating the weights. So whenever you did sea otter to translate, it would update. Then you do peppermint and it'll give you a translate, it'll update. So this does not do that. Without updating, it is capable of generating such outputs. This was one novel achievement by GPT-3. And parameter
going back on that one shot. So this one, I mean, how does it really do with GPT-3 if it is not doing any transfer learning incremental ML?
So if it is not adjusting the weights back, then how does it know that whether it is accurate or?
I didn't really understand what is the meaning of zero shot, one shot, few shot here if you are not allowing weight update, gradient updates.
So that is the beauty of GPT. The thing is, normally, if you were to suppose you're trying to do some sort of classification, there is some sort that in the training loop you do say with torch.0grad you update the weights, right? Like you do some sort of calculations. You do loss dot backward and optimizer dot step, and you do all that. So that is without the gradients being updated. So what GPT has done is they have also tried using the same technique. And the goal is that, see, how GPT does this is simply because of the model architecture. That is the beauty of a transformer.
Basically, so what we mean by incremental data in transfer learning, incremental ML, here we are saying the prompt is being provided.
Correct.
That prompt mapping is what we call a zero shot, one shot, few shot.
Yes.
So if you get three prompt mappings, then it is few shot.
Yeah.
One prompt mapping, it is one shot.
Sir, but the difference is you are giving it the answer in one shot. Like you are giving it the answer saying that sea otter is this output. And then you are saying predict for cheese. That is one shot. But in zero shot, you're not giving that example at all. So zero shot learning is where it performs. So this is the results. I was going to show you this.
So Akash, when you say that one shot or this multi-shot, few shot, right?
Yeah.
So it is somehow GPT should have some way of understanding this, right? It is based on the session or something. It is trying to manage that, or how is it like?
No, sir. As I said, it is purely NLI.
So it just stores that new prompt mapping in its corpus.
Correct.
Just stores it. It adds it to their database of prompts.
Vivek, what I'm trying to say is that it will be for that particular session only, right? So I clear up the session and again I have to give that, right?
Yes,
Means
yes. I
so
think
Yes,
there is
sir.
some
Yes.
logic in the session they are trying to manage, which I'm trying to understand.
Not only session, no, Suresh. It's like when we take that model and let us say we are customizing. I give a one
Example.
prompt,
Yeah.
one shot, and then say that no. Let us say conversational example itself. I'll call the GPT and then say that no, assuming that you are the conversational AI assistant for the Flipkart. That's
Mhm.
it. And then I say that like when will my parcel will arrive? This is the question I will ask, and I'll like say that no, yeah, it will be means like say that no, please track through your app or something. We are just giving the context saying that the questions will be asked and then it is particular to the domain of Flipkart AI assistant. So this is here we are giving in a kind of a few shot or a one shot. And this becomes the entire thing. No need to, it is not
No, no, see,
going away for
let's
the
say that
every session.
Anand, you do that, right? You do that, and
but
I
it's
open
actually
in.
not training. I'll give you a very simplistic example.
It's
Which
not a session.
no,
Yeah.
think of when you buy a new iPhone.
Mm-hmm.
So you take your photo
Mm-hmm.
when you're setting up your new iPhone.
Right.
It basically knows your face, and next time it can open the iPhone with your face.
Exactly.
It is
Right.
not training the model, which is a face recognition model again. It is just storing your face embedding. It is probably creating an on-device embedding of your face, and it knows it's authentic person.
Yeah, it's a
So
good
this is
example.
what we
Good
are doing
example.
here also, I believe.
So let's say that what Anand gave an example, right?
Hmm.
Let's say it does the Flipkart, right? He does it, right? Now, Vivek, you open your browser, right? Okay. And you try to give the same question.
No, same logic applies in face recognition in iPhone. If you change your iPhone, it would not know your face because your face embedding was stored in that old iPhone only. So again, you have to take a photo of your face with your new iPhone. So same concept. I
Suresh,
think it
yeah,
stores the embedding in
correct. Suresh,
that context.
assuming that like this Flipkart example, I'm building it as an API internally, I'm delivering it. It will
Right.
use it for my entire organization until I change it. So it is not a session based, it is a kind of application. My application is done with the power of GPT. I give one prompt and then it will answer anything which is available in the Flipkart corpus. And I open internet, whatever available about a Flipkart, it will answer. Your AI assistant
Mhm.
prompt, when you define as a prompt like you are a AI assistant of Flipkart, done.
Got it.
The,
Yeah.
yeah.
It will be stored in your OpenAI because you are calling the OpenAI as a key code, right? Authorization key. So it will be mapped to your authorization key. Anybody who calls that key will have access to that one thing you did.
Okay. So
True.
Akash, basically that embedding will be stored, what you are saying, the sample example there.
Yeah. Yeah.
Okay. Okay.
So coming back to this is the parameter-wise results. So more the parameters, I think someone had mentioned this in chat, right? As we increase the parameters, we get the results better. So that is what you can see right here. This is the blue is in 0 shot, the green is 1 shot, and the orange is few shot. So as expected, by giving few more learning samples, it is able to understand better and give you better answers. And this is your accuracy. So this is just the overall gist and correlation as to how 0 shot is related to the performance. And yeah, so how does it perform few shot learning? I mean, it is this part is really not really required, but I can tell you all the outer loop consists of the training of the crawler, right? The entire data set that you are provided. The prompt which you give is treated as a meta learning prompt. So this prompt is, as I told you, the weights change for every sort of task you want. Like suppose you asked a GPT to do go to like unscramble these words. This is what it's doing, right? Cycle words. So it is unscrambling the letters, and every time it is unscrambling, it is using that model and changing the weights according to what you want. So for goat, it'll be different. For snake, it'll be different. But then when you go back to bird, it'll still be the first model because there's no gradient update. So it'll be changing the weights for that particular word. That's all, just for understanding. So this is in context learning, which is happening inside like the specific task. And this is stochastic gradient descent during unsupervised pre-training was your outer loop, which was the crawler. So using that, you are doing some in context learning. Okay, and results, as I mentioned, so the model can do language translation very well from X language to English, but does not work well the other way around because I mentioned that GPT-2 used the byte pair encoding tokenizer, which was developed for an almost entirely English data set. So this was the backdraw because GPT they didn't realize this, OpenAI didn't realize this, so When they finished training, it was already like it had been a month, and like it had cost them a lot of resources. So they had decided that, for now we shall just leave it as a potential improvement. So if you see, French to English is being performed well over here, the dark blue line, but English to French is slightly lower. Same case for all other, like Romanian, and Romanian is just poor, very poorly done from English to Romanian. And this is the blue score. So, um, coming to achievements, yeah, so cycling and scrambling, and PETAR, it's capable of generating the correct word from the scrambled word. An anagram is where the first and the last letters are in their original position, but everything else is swapped. So again, an example of scrambling. And GPT-3 versus ChatGPT was what I wanted to talk about. So ChatGPT is primarily designed for conversational AI. So it is specifically for conversational applications. Like you talk to it as a bot, as a person to get your answers. So the training data is also different. GPT-3 is a more general model which can be used for a wide range of tasks. So you could alternatively ask it to do much larger tasks for you, whereas ChatGPT may not do it for you because ChatGPT has a context size limit. If you try to paste large code for ChatGPT, it'll say, please enter a message that is shorter. So that way, ChatGPT is a smaller model. The actual size is not released, but it is believed to be around 20 billion parameters. So it is still smaller than GPT-3, which has 175. And training data, it is trained on a dataset of conversational text, while GPT-3 was trained on the web crawler and web text, etc. So applications is for chatbots and virtual assistants, and GPT-3 can be used for text generation, language translation. So now we come to GPT-4, and towards the end, GPT-4, OpenAI just recently introduced GPT-4, a very large multimodal model. So we just saw large language model till now. But this is a large multimodal model, which means, why is it multimodal? Because it is capable of processing image and text inputs and producing a text output. So you can give it an image and you could ask it to do something with that image, but the output will be the text, of course. So you could give it an image and ask it to describe a story or what is going on in the image. Is there a meme you can make out of this image? Is there some, what contextual understanding can you get? So all of that it is capable of doing. So it has similar limitations to earlier GPT models. It is not fully reliable, and it has a limited context window. It does not learn from experience, as we had mentioned. So it has achieved better results to the problem of natural language inference and performed significantly better than GPT on exams as well. So these are some exam results that they had, performed with GPT-4 and GPT 3.5. So 3.5 was a version that GPT had also released, the Turbo, and these are the results comparison. So there are some different exams here that they have chosen, and GPT-4 seems to be performing significantly better, and this is the percentile score. So they are saying that GPT-4 is like almost an average student who takes exams such as these. So these were exam results, and this is a vision output. So if you give it such an input of three images, so they've asked it to, the user asked it to, what is funny, and describe it panel by panel. So it shows panel 1, panel 2, panel 3, and the description. So the description, it shows a package for a lightning cable adapter with 3 panels, and they've described the panel, in each panel what is happening, and the humor, plugging a large outdated connector into a small modern iPhone. So yeah, so it accepts prompts from both images and text, and we can do some sort of textual generation from the image. So yeah, it is not yet open to public access. It's still in an early development stage as far as I know, but apparently they're making a lot of developments very soon. And factual evaluation. So one thing GPT has struggled is providing facts, because the way GPT provides you an answer for facts is that it's only sourced from a single source. So from a single source, wherever it has got an answer for your question, it will give you that as the answer. But again, how do you know if it's real or not, right? Because it has got it from one source randomly on the internet. But so that way, facts, GPT 3 and 2 and 1 were not that great, but GPT 4 apparently has improved. So if you say, can you teach an old dog new tricks? And you say, you can teach an old dog new tricks, But then sometimes it gives you something completely absurd. So you can't teach an old dog. You can't teach an old dog new tricks. So this is son of an actor, the American guitarist. His name is Elvis Presley, right? But sometimes it gave Perkins. So these are the kind of cases that GPT-4 answered incorrectly. And yeah, so just the last slide as to how transformers are being used. Recommendation systems, image recognition, finance, and sentiment analysis. So recommendation systems, as we know, are very important in today's world for understanding your clients and audience better. Transformers are being used now as opposed to using collaborative filtering and traditional recommendation methods, and they're found to perform better because anything with text and data with in text format, transformers seem to perform better than traditional models. Image recognition as well. There are some vision transformers which has been specifically made for images. So they can do something such as security systems, medical image analysis, X-ray classification, which basically starts to eliminate the use of CNNs. And coming to sentiment analysis, it can be used for to analyze customer feedback and social media posts. So this could be useful in a business, right? So the reputation of their products and services based on customer feedback, and it could automatically improve the product and offer suggestions as to how to improve a product. And yeah, so in general, these are some of the use cases of transformers. The future scope of generative AI is vision-based GPT, more such either going in the direction of vision or adding speech, as Sir mentioned, and then artificial general intelligence, responsible AI, controllable generation. Controllable generation is becoming a problem because some people are using GPT for unethical situations, right? So controllable generation of content and specific fine tuning in case of businesses, and advancements in research and drug discovery. So yeah, this is the end of the webinar. Are there any questions?
Good session, Akash.
Yeah, thank you, sir.
Wonderful session, Akash.
Yeah, but as you attend such sessions, read more. There's a lot of open questions that come to your brain.
Oh, sorry, I didn't realize. I didn't. Okay. What are the questions? Is it possible to understand a difference between a text or book written with GPT-4 and a human? Yeah. So the thing is, written by GPT-4 and a human, this is what GPT is aiming to do. They're trying to generate text which is almost indistinguishable from a human's text. So if you were to, it's sort of like a hacking situation, right? You're the hacker, and there's a red hat hacker and there's a white hat hacker. So the white hat hacker is trying to defend the system from being hacked, and the red hat hacker is trying to hack. So here you're trying to generate text from a machine, and on the other hand, you're trying to build a machine which can detect, right? But detecting is always harder. Protecting a system is always harder because the attacker has multiple choices to attack the system. So this way, the same way, trying to detect text which an AI generates is still hard. It's like a battle between two AI models. And
Sir?
what- sorry.
Yeah, sir, I had a question.
Okay.
So like ChatGPT 4 is like a combination, like it's an integration of DALI maybe because it's understanding images, right?
Yes. So it's not DALI because DALI is completely different. It's a diffusion model. So here they're using, see, they've not actually mentioned in the report how they're using the image data, which is also why if you look online, researchers are criticizing GPT-4 paper because the amount of knowledge that you get from the paper is nothing. They just in 2 pages they mention about they don't mention about the data set. They don't mention about anything, the parameter, the model size. They don't mention anything, but they just show that the model can do this. So internally, when nobody knows how it is doing image, image, the features from image. It might also just be image captioning concatenated with some sort of things, because image captioning will give it a text, right? So from that text it can do its own generative prompts. So it could be a combination of that as well. Nobody knows yet. Okay, and are there any other question that I missed?
One quick question, Akash. So this you had a very interesting slide on the Chat GPT and GPT-3, right?
Yeah.
So this GPT-3 was developed first, and they were fine-tuned to specific to this conversational chat. Can I understand like that?
It is not, yeah, I mean, it is not, it is based off GPT-3,
Yeah.
like the way GPT-3 was built and everything else. It has been based off it, but it is not the same model because it has 20 billion parameters here, which is lesser, right? So they have just basically reduced the blocks and but they've just taken GPT-3 and reduced the size. That's all.
Okay.
And the data set is now like conversational text, so like question answer, question answer, question answer, links, YouTube links, code links. Like if it's a massive data set where they scraped links from, as I told you, GitHub for code, YouTube for transcripts. So this was the training data for chat GPT, which
But
is because it is focused on conversational AI, whereas GPT-3 was trained on a very broader data set.
okay. So basically, you mean the data, even the data set was different for Chat GPT and GPT-3?
Yes, the data set is different because GPT-3 focuses on a user interaction rather than some sort of complex text generation.
Okay.
Yeah.
But why does the whole world talk about? I'm really kind of. It was a really eye opener for me because I also was thinking that Chat GPT is based on GPT-3.
Yeah, I mean, it is architecture based of GPT-3. The architecture is slightly similar. There
Okay.
are lesser blocks there, but the training data is different.
So when you say lesser blocks, the decoder blocks, there are
Yes,
12 in
yes.
GPT-3, whereas
No, no,
in
no. There's 12 in GPT-1, but GPT-3 has many, many more.
okay,
GPT-2 has lesser, but ChatGPT has somewhere between GPT-2 and GPT-3.
okay.
Yeah.
Mhm.
And if you see the GPT, Chat GPT's API, how that's been used is the like a user and agent. So how that's
Correct.
how the data has been feedback to the network. So that's how they remember the context
Yeah.
and
Yeah.
try to give the answer. While in
Exactly
GPT,
what Vivek sir mentioned, right? From the API key, like the iPhone situation also,
Okay.
whatever prompts have been generated goes to your knowledge base
Mhm.
specifically.
Okay.
So, yeah.
and one thing Akash wanted to add that like similar to the zero shot or the one shot or the few shot classification, we could add some examples into the Chat GPT as well. So that's the only
Mhm.
fine tuning that can be done, or is there any more fine tuning we can do with Chat GPT?
So, I mean, as we had spoken earlier, because Suresh sir also had the same question, right? So, the thing is, you can do fine tuning, it's not wrong. But if you have a very, very specific data set, like specific prompts, like let's say you're in like a very, like you have confidential information, right? And that confidential information was not available for GPT-3 to train on. So, but you want to automate your task, right? So you will create an instance of GPT-3 and train it specifically. I mean, not retrain it, train it, my bad. You will fine tune it on your specific data. So that way you can use GPT-3 for it.
Even in the scenario when the Chat GPT is outdated one and the latest data is available, is got updated. In
That's
that
okay.
scenario,
That's okay.
that
Because as I mentioned, the only difference between GPT so far is the decoder blocks.
yeah, but the data sometimes we get wrong from the Chat GPT as well. So how do we encounter that one? Though we
That
have the
is
updated data, but ChatGPT has the outdated data. So how do we encounter that?
See, so if it's data issues, because see, ChatGPT again, yeah, it was trained up to 2021. So if
Mm.
you have newer data, you can probably, Vivek sir has mentioned that you can request the OpenAI and they will fine tune the model for you, right, for your specific data set. So if you have access to some sort of text or music or poems from 2022, anything you want, basically, if you, as long as you have the data set, it is possible, basically.
But where is that possibility? I mean, I'm not sure that OpenAI will do for us.
No, no,
So
I tried doing the fine tuning. Okay, so
for
actually,
ChatGPT,
you just need to have the token and things, right? And this is just one command you need to provide, right? And you give your prompts and things. Okay, it will
Hmm.
create a model for you. Okay,
Correct.
and you need to
Yeah.
refer to that model. Actually, I used that. I trained it and things. It's very
For the
very simple. Very
GPT,
simple.
GPT-3, I have trained it.
Yeah.
ChatGPT, I could set up the prompts and set up the examples. Apart from that, I could not do anything from the ChatGPT. So are you saying that you have?
No, I
Uh,
tried GPT-3. Sorry, I didn't
yeah,
try Chat.
GPT-3, I have trained it. I'm asking about the ChatGPT.
ChatGPT, we're still not sure because the
Yeah.
API key that we have right now is for using an existing engine. So that's why. That's the thing with ChatGPT. We're not
The
sure yet.
APIs that OpenAI is giving is not based on ChatGPT 3, right? No, sorry, GPT 3, nothing to do with ChatGPT.
No,
No,
because
it's
ChatGPT is available right now, right? You can just
you
enter
can use
whatever
the
you want.
same token. You have to just change the model to
Yeah.
Turbo. So that's the only thing we have to do for the ChatGPT, and
Okay.
rest of the things is the same.
Yes,
And
yes, you're right.
I use mostly the LangChain or the GPT index library to train it. So somebody else has used any different library to do that, or somebody aware about this particular library wanted to explore more on that side.
Sorry, I couldn't hear. I can understand your
So
question.
have you heard about the LangChain library and the GPT index library?
I am not very sure about them.
So
No.
yeah, we have some people who are working on LangChain also.
Okay.
So we have a goal to present a series of these webinars, right? Because obviously there's so much new stuff we all have to grasp. So we will
Yeah.
be presenting many webinars and many of these topics we'll cover.
Okay.
But I
Yeah,
did
sir.
see somebody yesterday in our in-person meetup, somebody was talking about LangChain as a very easy way of customizing GPT or
Yeah,
fine-tuning.
because I use a GPT index and the LangChain OpenAI one, so to fine tune GPT models rather than using their other instructions over there. So, but there are more to explore and more to know about that. So that's all.
Yeah, agree. There's a lot to learn.
Yeah.
It's coming very fast, actually.
Um,
Okay, any final
Yes, sir.
question? Given the time, one more question. Lot of intense discussion. This will continue over our subsequent sessions. Fantastic presentation.
Also, I just wanted to know feedback. I mean, was it good or any?
No, good. No, Akash, it was very good. It was rather eye opener. Probably in the session you give, then you'll have answers to that. Probably, yeah. I know it is evolving area, and yes, no, it was very
And you put
excellent.
it in a very simple way, like the
Right.
complex concepts and
Right.
all in a sequential order, and that is very good,
Uh-huh.
Akash.
Thank you, sir. Thank you.
Yeah, because I've been also reading so many articles, but after your sessions,
Yeah, but trying to understand what they're saying is the problem, right? Yeah.
yeah, interpretation. No, there are no many blogs. I don't know authenticity of these blogs also, right? So everyone
Yeah.
have their own interpretation. But it was good, excellent, Akash.
Thank you, sir. Thank you.
Great session, Akash. Thank you so much.
Thank
Okay.
you.
Thank you all. Thanks, Akash. We'll look forward to our next set of sessions, including from Akash as well. Almost every weekend we have these generative AI sessions, if you notice our schedule.
Yes. Sir.
Yes.
Thank you.
Thank you.